Welcome to this explainer. Today, we're jumping right into the massive energy footprint of pulp and paper manufacturing and the incredibly complex strategic dilemma of exactly how that energy is sourced. I mean, think about it for a second. Think about the paper products sitting on your desk right now, or the cardboard packaging that literally just arrived at your front door. Creating those seemingly simple items requires an absolutely staggering amount of industrial power. And how these companies actually choose to generate that power? Well, it happens to be one of the most critical sustainability and operational challenges they face today. Here is our agenda for today. We'll start with 1, the energy heavyweight. Then move to 2, grid versus self-generation. 3, the Biomass Balancing Act. 4, sourcing and regulatory risks. And finally, 5, walking the tightrope. Section 1, the energy heavyweight, the massive footprint of paper manufacturing.
So, a typical pulp and paper facility doesn't just sip a little bit of electricity. No, it guzzles millions of gigajoules. To put that into perspective, a single large facility can use as much power as an entire small city. According to the SASB Sustainability Accounting Standard for Pulp and Paper Products, this massive energy demand comes from stationary and mobile engines, cogeneration fuel boilers, wood chip pulping, and those giant high-pressure chambers. Managing this energy efficiently isn't just some nice environmental goal. It's fundamentally tied to a company's cost structure and its basic operational survival.
Section 2, grid versus self-generation, choosing the power source. To actually meet these staggering energy demands, mill operators face a pretty critical fork in the road, and they have to carefully break down their energy mix. Under the SASB standards, specifically metric RRP-138A.1 for those keeping track, companies are required to disclose their total energy consumed and segment it into very specific slices. We're talking the percentage of grid electricity, the percentage from biomass, and the percentage from other renewable energy sources. This level of transparency is huge because it reveals exactly how much a facility relies on buying power from an external utility versus just generating it themselves, right there on site. And that creates an immediate high-stakes trade-off. See, by sourcing from the grid, a mill becomes highly vulnerable to market cost volatility and is just completely reliant on external infrastructure. On the flip side, generating energy on site, which is predominantly done through burning biomass, can offer this vital energy independence and drastically reduce the costs associated with purchasing fossil fuels. So on the surface, self-generation looks like a clear operational winner, right? Well, not exactly. Section 3, the Biomass Balancing Act, the hidden costs of renewable energy. Because here is where our story gets super complicated. Using self-generated biomass isn't just a simple, perfectly green solution. We really have to ask ourselves about the incredibly counterintuitive reality of burning our way to energy independence. What kind of immediate environmental and regulatory challenges does all this combustion actually create for these facilities? Okay, so when a mill burns biomass or fossil fuels on-site to generate its own power, it is directly creating Scope 1 emissions. As defined by the Greenhouse Gas Protocol and tracked by SASB, Scope 1 emissions are those direct greenhouse gases released into the atmosphere from sources the company outright owns or controls, like those massive on-site cogeneration boilers we talked about earlier. By generating their own power, companies put all of those emissions, including carbon dioxide, methane, and nitrous oxide, squarely on their own regulatory ledger. And depending on the prevailing regulations in their area, high Scope 1 emissions can trigger some massive compliance costs. But wait, there's more. This on-site combustion also creates severe local air quality risks. Beyond global greenhouse gases, burning fuels generates a seriously nasty cocktail of local air pollutants. We're talking everything from nitrogen oxides to hazardous volatile organic compounds. Simply installing the technology required to clean the air coming out of those smokestacks requires significant capital. The source documentation actually highlights that while industry emissions have declined overall, these abatement expenditures remain absolutely enormous. And with evolving air quality regulations creating immense uncertainty, failing to manage this can lead to major operational disruptions and some really severe financial penalties. Section 4, sourcing and regulatory risks. Navigating the compliance minefield. Beyond the smokestack itself, relying heavily on self-generated biomass exposes a company to a really complex web of external pressures. The SASB framework requires entities to explicitly describe the risks and uncertainties associated with using biomass for energy. These hazards include potential financial hits from looming biogenic carbon dioxide regulations. Plus, there's the risk that the biomass they're burning might completely fail to meet the definition of eligible renewable energy in a local jurisdiction's renewable portfolio standard. And perhaps most critically, there is a massive reputational risk here. Without perfectly transparent sourcing, a company could face intense public backlash for unsustainable harvesting practices. In fact, to safely claim biomass as an eligible renewable energy and avoid those reputational and regulatory traps, it really isn't enough to just burn random wood scraps. The fuel often must be backed by rigorous third-party certifications. The SAB standards actually specify that to be counted properly, biomass energy should meet criteria like certification from the Forest Stewardship Council, the Sustainable Forestry Initiative, or the Program for the Endorsement of Forest Certification. This is absolutely crucial because it ensures the fiber originates from sustainably harvested sources that respect environmental and social criteria, land rights, and biodiversity. Section 5. Walking the tightrope. Strategic decisions in the boardroom. So as you can probably see by now, running a pulp and paper mill is essentially an endless tightrope walk. Executives are constantly having to balance two competing strategies. If they go with grid-sourced electricity, the big operational pro is zero direct Scope 1 emissions, but the huge con is being totally at the mercy of grid reliability and wildly fluctuating market prices. Now, if they choose self-generated biomass, the operational pro is incredible cost savings and that sweet energy independence. But the massive cons are the heavy burdens of those Scope 1 emissions, incredibly expensive air quality compliance, and the really complex challenge of transparent, sustainable sourcing.
And honestly, this is exactly why accounting frameworks like SASB demand such incredibly granular reporting. Investors and regulators use these specific disclosure topics, from gross global Scope 1 emissions all the way to energy management percentages, to evaluate how skillfully a company is actually managing this exact trade-off. Because a company that can cost-effectively manage its emissions through greater energy efficiency and smart alternative fuel use, they aren't just saving the planet. They're vastly improving their operating efficiency, they're lowering their cost structure, and they're drastically mitigating their regulatory risk.
Which leaves us with this final, provocative thought. We've seen the incredible scale of energy required to make the paper products we all rely on every single day, and we've explored the really precarious balance between buying power and burning fuel on site. So, as global environmental regulations continue to tighten, and the true cost of air emissions and sustainable sourcing becomes fully realized on the balance sheet, how long can heavy industry rely on burning its way to energy independence? Is the financial benefit of self-generation ultimately going to remain worth the ever-growing regulatory and reputational risk? It's a massive question, and it's one every pulp and paper executive is wrestling with right now. Thank you so much for joining me for this explainer. I really hope this helped illuminate the complex mechanics of industrial energy management